All right, we're going to look at transformations, um, which should be review, and so I'll probably go a little bit faster, but feel free to slow it down or pause it whenever you need. So we need to be able to recognize parent functions, which is the most basic equation or function for that function family. And so these are some examples of parent functions. Quadratic, we have radical, linear, rational, absolute value, exponential. Um, we also have like higher polynomial ones and logarithmic, but we're just kind of looking at these. So for our table, we're going to go through what the rule means, and then we're going to apply that rule to the example where there's only one rule, and then we'll look at like a combined example that has multiple transformations that occurred. So if I am adding on the outside, I am going up that many units. And so here I would say I'm going up 10 units. If I am subtracting, I'm going down. So this minus 8 is on the outside of my radical. If it's on the outside of parentheses or the outside of absolute value signs, that would still mean I'm going down. So down 8 units. And you want to be specific, so I need to know the direction, like how it's moving, and how much. So I need both. If you just say up, you would not get full credit, and so I need the direction and how much. If I'm adding on the inside, I am going to the left that many units. So here, if I have plus 3 on the inside, I am going left 3 units. And then if I have minus on the inside, I'm going right that many units. So my minus 2 here, it is on the inside of my absolute value sign, so I'm going right 2 units. When I have a negative, I am reflecting the graph or flipping it across one of the axes. If my negative is on the outside of my function, out in front of everything else, I am reflecting it or flipping it across my x-axis. So this is the same because my negative is on the outside of my radical. When my negative is on the inside, so on the inside of parentheses, on the inside of absolute value, on the inside of a radical, we are still reflecting, but this time we are reflecting it across our y-axis. So for the example next to it, we can see the difference between this one and the one above it. This negative is on the inside of the radical, so it's being reflected across the y-axis. I'm going to scoot this up. Now we're looking at some stretching or compressing. So if we have a number that's being multiplied on the outside of our function, so it's out in front, it is a vertical stretch or shrink. So you can say compress or you can say shrink, whichever you prefer. Means the same thing. We're kind of squishing our graph. So if our constant that's being multiplied is greater than 1, so 2, 3, 10, 105, that would mean that our graph is stretching vertically, or there is a vertical stretch by whatever that number is, whatever that constant is, or by a factor of that number. So here I see my 3 is on the outside. So we're going to say there is a vertical stretch by 3. If you just say stretch by 3, you would not get credit because I need to know if it's a vertical stretch or a horizontal stretch, and I need to know that you know the difference between those. If the number out in front that's being multiplied is between 0 and 1, so we want to think decimals, 0.5, 0.25, 0.8, or fractions in between there. So 1/2, 1/3, 1/4, 2/5, 2/3. So in between 0 and 1, we have a vertical shrink or a vertical compression. So for this example, my 1/4 is out in front, and so I have a vertical shrink by 1/4. For the last two rows, we're looking at if the number being multiplied is on the inside of the parentheses or on the inside of the radical sign, on the inside of absolute value, anything on the inside. If that number is greater than 1, so, oops, can't spell horizontal. Because it's on the inside, that tells me it's going to be horizontal. When it's greater than 1, it's actually being shrunk. So it's being compressed. So I'm going to say it's a horizontal shrink. And we're going to say by a factor of, oh my gosh, I ran out of room, whatever the number is. So technically, it is being shrunk by the reciprocal of that number. So if it was 5, it's being shrunk by 1/5. If it was 2, it would be a horizontal shrink by 1/2. But to make it a little bit easier, we can say by a factor of that number because that fraction is a factor of whatever number we see. So for this one, my 3 is on the inside. It is bigger than 1. So I have a horizontal shrink by a factor of 3. Or you could say a horizontal shrink by 1/3 because the reciprocal of 3 is 1/3. So I'm going to add that here. And then the bottom one, this is if our constant is between 0 and 1. So again, those decimals or fractions, as long as they're less than 1, it is a horizontal. This is a stretch by a factor of that number. Because again, it is being stretched by the reciprocal, but I think this is easier. I also realized this is a typo because technically right now this fraction is out in front, and so this would be the same as this example. So we're going to fix this. I want you to make brackets or parentheses with the exponent on the outside. So now our 1/4 is on the inside, and so this would be an actual horizontal stretch. So we're going to say horizontal stretch by a factor of 1/4. So for this example at the bottom here, I'm just going to draw some arrows for the transformations and where they are in the graph. So this 2 is on the outside because there are brackets and parentheses after it. So it's on the outside, it's bigger than 1. So this is a vertical stretch by 2 or by a factor of 2 because we don't do the reciprocal of that one. I am going to kind of change my colors here. So this negative sign means something. And this one's tricky because we do have parentheses as well as brackets. Since this negative is still inside this bracket and the entire bracket is being raised to a power, we're going to consider this as being on the inside. So a negative on the inside is a reflection across our y-axis. Let me scoot that over a little bit. Oh, I'm so sorry. Our variable doesn't mean anything because our parent function for this is our quadratic parent function, which is x squared. So we're going to move on to this plus 5. If I'm adding on the inside, I am going left that many units. So say left 5 units. And then my plus 9 means I'm going up 9 units. That plus 9 is on the outside of everything, so I'm going up. So we're going to flip to the back. And I'm not going to do all the ones on the back. I want you to try some on your own. And so any that I don't do will be on the answer key. I want to go through this one, and I'll talk about why in a second, and then we'll go through like this box down here. This one causes some issues because people look at this and they think there are only 2 transformations. There are actually 3. So the plus 10, usually we get right away. We are going up 10 because that is being added on the outside of our absolute value sign. The negative 4 has 2 different transformations. So the negative means one thing, and then the 4 means something completely different. And so that is where we see a lot of mistakes. So the negative, because it's on the outside, is a reflection across the x-axis. And then our 4 is a whole number bigger than 1, and it's on the outside being multiplied in. So we are stretching vertically by 4. So the 3 transformations for that one. So at the bottom, I'm going to go through the first box and I'm going to leave the bottom one as your U try. So I have the given parent function, so I have f of x equals x squared, and I want to use it for the next 3 examples. So I need to perform the indicated transformation and interpret what the new function would look like. So I think how it changes graphically is the easier column to do first. So I'm going to start by doing this. So looking at here, this one, I notice I have plus 7 on the outside. So that means it is going to go up 7 units. When I write my new function, I'm going to take this f of x out and I'm going to put my function in place of it. So instead of having f of x plus 7, well, I know f of x is x squared, so it's going to be x squared plus 7. For my second one, I have that minus 1 on the inside of parentheses, so I know it is going to the right 1 unit. And this time it's different because I have an x minus 1 inside my parentheses. What that means is this x minus 1 has to go in place of this variable here. So I'm taking this x out, I'm going to put x minus 1 in, and then I keep everything else. So I'm going to use 2 different colors here to show that. So my x minus 1 is going in place of this variable. That exponent 2 is still there on the outside of the parentheses. And then if I had something else on the outside here, I would put it on the outside, but otherwise that's my final answer. And then the last one, I look over here, I notice I have a negative 2. I don't want to be fooled, there are 2 transformations. So the negative means we are reflecting across the x-axis. And then the 2 is a vertical stretch by 2. So inside my parentheses is just my normal x variable. So I don't have to worry about doing what we did in this one. My negative 2 is being multiplied to my entire function, so I can write it as negative 2 times x squared, or I could write it as negative 2 times x squared. That would be fine. I guess there's a third option. I realize I wrote too big. I can do negative 2 x squared like that. I think this is the best one when I don't have to have parentheses to make it look more complicated. You should try the U-tries on your own, so the ones down here and the ones at the top, and then double check the answer key to see that you're doing it right.